Here's the formula that's given to you in the formula book for C4 binomial expansion. I'm actually going to write it a slightly different way, which I think makes it a bit easier to use. So instead of, it's important it starts with a 1, but instead of an x I'm going to use a y, and the reason for that is that usually what you're going to expand is things like 1 plus 3x, or 1 plus x over 2, or 1 minus x over 3, or something like that. So x becomes x over 3, and rather than thinking x equals x over 3, I think it's nicer to think y equals x over 3, so you're not muddling your x's. Okay, n in this case can be any number you like. N is any real number, so whereas in the C2 binomial expansion it had to be a natural number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. In C4 it can be any number you like, negative, fraction, whatever. Okay, equals, obviously the first term is 1, and then the second term is nx, so I'm going to write ny, and then the next one is n minus 1 over 1 times 2. Okay, I'm going to write that as n minus 1 over, like this, 1 over 2 factorial, because that's going to show up the pattern. And then I've got y squared plus. Now if you look at the next one, this is where the formula book I think gets a little bit complicated. There is no third one. Then they jump straight to n minus 1 all the way down to n minus r plus 1 over 1 times 2 all the way up to r times x to the r. So I'm going to do a couple more for you to see what is actually going on there. The next one will be 1 over 3 factorial n minus 1 n minus 2 y cubed. And the next one will be 1 over 4 factorial n minus 1 n minus 2 n minus 3 y to the 4. And the next one, hopefully you can see the pattern now. So what's down here is r factorial. R is this power up here, and this is 1 times 2 times 3 all the way up to r. So if that's a 2, that's 2 factorial. If that's a 3, that's 3 factorial. If that's a 4, that's 4 factorial. The thing on the top is n minus 1, n minus 2, n minus 3, n minus 4, like that. And we go down and down, taking 1 off each time until we get to n minus r plus 1. Note that it isn't n minus brackets r plus 1. It's n minus r plus 1. So here, r is 2, I stop when I get to n minus 1. R is 3, I stop when I get to n minus 2. R is 4, I stop when I get to n minus 3. So this is the way that I like to think of the binomial expansion of 1 plus y to the n, and that's what I'll be using, and it's valid provided that your y is between minus 1 and 1. That's what that means. Modulus of x is less than 1, so I'm going to write provided minus 1 is less than y is less than 1. That's when it's valid. Let's have a look at a couple of examples. It's really easy, just stick everything in the formula. 1 minus 2x all to the minus 3. Let's go up as much room as I've got. So n is minus 3, y is minus 2x. 1 plus n y plus 1 over 2 factorial n minus 1 y squared plus 1 over 3 factorial n minus 1 n minus 2 y cubed plus etc etc etc. I've run out of room equals 1 plus 6x. Now just do this slowly, don't try and jump too quickly. What have we got on the top? 12. What have we got on the bottom? 2. That's fine, let's leave it like that. Minus 2x squared is 4x squared. No need to just like leap ahead and get to the answer. Okay, I've got a 6, I've got 3 times 4 times 5, 12 times 5, 60. I've got 1, 2, 3 minuses, so that one's negative. Then I've got minus 8x cubed plus, like that, equals, and then you can tidy it up. I think that's right. Obviously the more terms the better, and this is valid if y is between minus 1 and 1. So multiplying everything by minus 1 and flipping the sign like that, which can be written as minus 1 less than 2x less than 1, and then dividing everything by 2, you get the condition that it's valid if x is between minus a half and a half. Okay, one more example just to show you about as hard as it can get. If your original starting point isn't written in the form 1 plus y to the n. Now, obviously, first step's pretty straightforward, isn't it? This is 3 plus 2x all to the minus a half. That's fine. Now, what we need to do is make that 3 into a 1. So we pull it out of the bracket. 1 plus 2 over 3 x to the minus a half. And this bit is really important. This power of minus a half does not just sit on the bracket, it also sits on the 3 when the 3 comes out. So what we end up with is 1 over the square root of 3, that's 3 to the minus a half, times, now we do a normal binomial expansion, 1 plus n y plus half n minus 1 y squared plus etc, 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 and then tidy it all up and times it by 1 over root 3 at the end. So it's not a lot more complicated, but that's as complicated as it gets.